Okay, hello. Um, so something new starting for me, a new project, another database. I'm calling it ChunkDB, of course, being written in Odin and probably a little bit of C. It depends. I don't know. Right now, I'm comfortable with just being Odin, but I think C would be pretty fun to slap in here somewhere. So First of all, Ostrich DB, right, is generally speaking, I'm kind of done with it. It's time to move on. I've been working on it for a year. I've worked on several iterations and projects for Ostrich DB. Started with the CLI tool. Then I iterated over that and made an actual HTTP server and all that with the database engine, and you can deploy that somewhere. Then I made Ostrich Lite, or I was working on Ostrich Lite. That didn't go very far, but I did make Open Ostrich DB, right? So it's a whole thing. You got the web application, you got a couple SDKs that are not fully finished, but they kind of work. Um, fun project to build. I decided, or rather, before I decided anything, I learned several lessons. Okay, so Ostrich DB is literally just a plain text, like it stores data as plain text. So you have a file, right? And then literally everything in it here is just plain text, hello world. And then what happens, or what's supposed to happen, is that's supposed to get encrypted. Um, but that's not the best way to do things because every time you needed to read or write or get some data, you would have to read the entire file. And let's say you got, I don't know, let's just try something here real quick. I'm gonna show you. Boom, 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 boom. See how quickly we can like do this. What I'm showing is basically if we have a piece of data that's all the way down here in this file, right? We'd have to read the entire file, no matter how big it is, despite the limit set on the file, which I don't even think I set a limit on database file sizes. Technically, you'd have to have the machine read every single line to find that information because I didn't add in any kind of indexing or anything like that, right? So what would that means that essentially that would have been a slow fucking process to just get anything when you have a large enough database, right? Storing things as plain text and not having indexing or anything. I don't know how to build indexing. I still don't, but I would like to learn and do some research. So ChunkDB is going to be a little bit different. ChunkDB is essentially going to have I call it ChunkDB because it just makes sense to me. Apparently, several databases use something called pages, and pages are not what you would think. In my opinion, when I hear the word pages, I think of several files or several pieces of paper. Um, but that's not correct in this usage. Technically, this everything between line 1 and 8 would be a page in the same file. Everything between line 8 and 14 would be a page. That doesn't make sense to me, right? I don't like that. So any data in here is a part of its own page. I don't like that. So in my opinion, they should be called like something like chunks. It just makes more sense to me. There's chunks of a file. So that's why I'm calling it ChunkDB. And shout out to Cobb Coding, of course. He had the idea, gave me the idea of perhaps storing things as like a bytecode format. And so that's what I've been working on. So ChunkDB will store data as bytes, like straight up. Like obviously you're putting bytes on, rewriting bytes to a file normally, but this will be literal byte code. So for example, if we go to our main.odin file, um, we have, let's actually start with our types. Types. Why is it doing that? I just saw it. Types. There we go. So I'm taking some inspiration from DB because that stuff still makes sense to me. You will have kind of like a project layer, right? And inside projects, you will have an DB, we call them collections, and here we'll just call them databases, so straight up. Um, and then inside of a collection, you would have a cluster, and here I am calling them, did I call them, let's see, I think I'm calling it projects, regions, collections, or databases. Clusters and ostrich DB are, what am I calling them? I think I'm just calling them records. Yeah, records. And then records and ostrich DB are now being called fields. Okay. So what you see in parentheses is what I'm kind of going with now for ChunkDB. So we have um, a record which has several fields. Fields have a name length, a type, uh, the value, and a value length. Okay. So I'm learning this like a lot of stuff. I took CS for like a half a semester. I was like, dude, fuck this. And it's not really biting me in the ass, but it definitely it definitely would have helped if I stuck around a little bit messing around with this shit. So I'm kind of learning as I go using some AI tools that kind of help me explain shit. Um, so we are current, let me go back to main. We have a field. All right, remember I said fields have a name length, a value, a type, and a value length. So let's just run it and see what we get. Let's see what bytecode we get. Oh, I gotta comment that out. Okay, so there we go. So here are our bytes. So we go back to main. User age, right? This string value has been serialized into an array of bytes. We know that it is the length is 8 bytes, right? I think that's what that, yeah, yeah. Or 8 elements. Yeah, yeah, 8 bytes. Yeah, 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 yeah. Okay. And it's the type is two. So we have a this here, right? I'm making these types here. Uh, bring this down a little bit. And bear with me if I make a mistake. I'm not a fucking database engineer. I'm not a computer scientist. I'm a developer who's self-taught, and I'm learning some really fucking annoying shit right here. So I'm gonna make mistakes in the things that I say. It is what it is. Um, and then our value. I give it the value of 30. Here we go. So this byte can hold up to 255, a value of 255. So 30 fits within 255. So I'm only using this byte, if I'm not mistaken. Okay. Um, yes. All right. So I hope that's kind of making sense. I'm hoping I'm explaining it correctly and well enough for anyone watching. So this is kind of what I'm working on now. So we are able to serialize fields. So what would happen next is we'd want to take this data, essentially the actual bytes in this array here, and store it or write it to a file. Now, let's be clear. Let's let's say this is our database file. We will have chunks. So the first chunk will be the database header. Okay. The next chunk will be indexing stuff, which I'm not working on right now. Um, and then let's call it the metadata, indexing stuff. And then the next chunk will be, I think, actually, hold on. I'm missing something. Chunk directory. There we go. The chunk directory, the bitmap, data chunks. Okay, that's right. Boom, boom, boom. Where'd you go? AI tools are great because it can help you explain some things, some really good concepts. So, and then we have our chunk directory. Actually, I don't even need to continue writing it. There we go. It's right there. Okay. Chunks are pre-allocated. That's why I'm being very trying to be very particular about the data that I use. Like everything's unsigned 64-bit, 16-bit, 32-bit, or 8-bit integer, or an array of uh, that 8-bit integers. Um, or slice, I guess, technically, but then it's an array. So everything will be represented as such. So I have, I think I'm losing focus here, but chunks are pre-allocated in size, so they cannot be larger than X amount of bytes or something like that. So our magic number, if we go over to constants, here's our magic number, the string, right? Well, we serialize a string. If we go back to our serializer here and serializing string right here, takes a string and then transmutes it into an array of uh, bytes, an array of elements within byte. Yeah. It's confusing to me sometimes to even explain the shit, but this is how I sometimes learn. It helps me learn this way. So, our next step is going to be to decide, first of all, writing to the fucking file is going to be probably the next thing, just so we can get something essentially like a hello world, literally a hello world in the file. And then deciding about pre-allocation and then writing something that can read that stuff. Right. Um, okay. So let's write to the file. Let's make this full screen too so we can package data. S one. You know what? Actually, let's go back to types real quick. So we have a field type. We need our database header type. There it is. So we need to create a new one of these. Database header. Um, this is going to return new lib dot database header, and we're going to import // lib. Okay, I don't know if we want to make it a pointer too. Uh, 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 no, new, no, it's just new. Well, no, yeah. New lib database header dot. We'd have to serialize the data. I mean, we could set this magic number equals header dot serialize string, and we're going to do lib dot magic number and header dot created. So we also need to do that for time. Now we could put time into a string. Sorry, 64-bit integer codec. Actually, we may not need to do that. Serialize, and then we can do time dot now, I think it is, or time, no, time dot now. Time.now returns what? A time. A time needs to be represented as, okay. Uh, oh, it's a signed 64. Hmm. Um, current time equals time dot now. Current time dot insec. Uh, wait, what is insec nanoseconds? Where am I looking at? Where is that at? Oh. Measured in Unix nanoseconds. Okay. So time or can I do this? Transmute. I don't know if this is possible. Is that possible? Nanosec is now U64, so we want to serialize U64, so we just do nanosec. Now it's not going to codec serializer, so nanosec of type 2. Wait, can I make this dynamic? If I make that dynamic, mm, 64, right? Just return a trans. Hmm. Class and value codec of type. Oh, you know what? Because created at is U64. Okay, so I'd have to make my own, another, not my own, but like another serializer that would just take a value and append it to a slice of bytes that's not given a specified or fixed length. U64 unfixed or something like that. Um, 64. Uh, U8. Oops. No, see, we don't need that. We just need it to be a slice. And then we can just take that and then val. Okay, hold on now. So val. Can I transmute? Can I trans? Do we have to put in like a buffer or some shit? Can I transmute val to? What has to be a string? Thanks. How do we make it grow? How would we handle that? It's still fixed size. Can we just make it dynamic? Versus 40. I don't like this little checker thing here. 8 versus 40. Oh, how am I trying to do this again? So we're trying to store created at, right? Unsigned 64-bit integer. Serialized U64 returns. Ah, so I don't need to do that. I can just pass date nanoseconds. But right. Wait a minute. Wait a minute. Hold the fuck on. If I just pass this nanoseconds, when we need to store it, that needs to still be transmuted into bits, right? Let me delete that for now. All right. So, oh, you know what? Ah, wait. I said oh, but I don't understand what I just did. So this is going to be what? 4 bytes, 4 bytes, 8 bytes. Okay. That's the representation of it's the representation of that in the file will be 8 bytes. So as we store it here, it's just the number, it's just the nanoseconds. So do I need to serialize that? Because we want to take this data. You know what? Let's just fucking print out. Let's just do this real quick. Mm, uh, declare make the honors system so data dot make the header. Uh, oh, not returning. Damn it. Wait a minute. This is a pointer two. We don't need to do it this way. We can just do header is type db header return header. Right. Okay. Okay. So there's our magic number as an array of bytes. Now here's our nanoseconds, but they're just okay. So we would want to store that as bytes. Now, my thing is, since we're storing it as nanoseconds, and that would be the representation of it, I need to make sure we actually allocate enough space. So use unsigned 64-bit integer, I think, should hold this number. Let's go ask our best fucking friend in the world, Claude. And use 64. Obviously, I mean, I would imagine, but the problem is this number continues to grow no matter what. easily, it says. Um, your timestamp represents approximately this. You max can hold this. It represents the date. Okay, so oh shit. Okay. Well, we're good then. So yes, we can, that's fine. So we can hold that. Um, Now my question is storing it. We need to store it as, so we need to change these two. No, it would need to be, yeah. Would it need to be array of 64-bit integers? No, it wouldn't need to be because one single 64-bit integer or 60, yeah, God, this stuff's confusing. So one 64 unsigned 64-bit integer can hold up to whatever Claude said to like in nanoseconds. So I don't need an array of that. But we do need to serialize it into bytes. So it does have to, this is not just going to be that number. We want everything to be like that. So this should actually be, can we do that though? Or do we make it dynamic? Um, so nanosecond is currently that. So we would need to do codec dot serialize A64. Okay, no, serialize, yeah, wait. Unsigned 64-bit integer. Right, this is unsigned 64-bit integer. This takes in an unsigned 64-bit integer. Oh, um, that only, that's right. This is where our problem goes back to where we have a fixed, so it has to be 8 bytes. So I have to make another. How many fucking bytes would that be? God, I think I'm going about this very wrong. The part for me that's confusing is remembering that the data that's stored in memory is not going to be the same that is stored in the file. The byte representation of that is going to be stored. The byte representation of what's in memory will be stored in the file. And it keeps, this is confusing the shit out of me. Um, we can't just store that in eight. Yeah, maybe we can. We might be able to actually. So let's change our type back to. Okay, there it is. There's our nanosecond byte representation. So the same thing should be used for date last modified will also be an array. Okay. Um, so header dot last modified at is going to be the same. Let's change this actually. Current nanosecond. It's going to be the same exact thing. Oh wait, no, no. Wait a minute. Wait a minute. Wait a minute. Oh, yes. Okay. So header dot size pre-allocated. I haven't done anything with. Um, Total capacity is going to default to lib dot. Oh wait. Oh, total capacity is not the same as max capacity. So size pre-allocated and total capacity. I need to first fucking get everything, the chunks stored and to see how big all of that is together, how much that is. And then I can set the size pre-allocated. And then once data, the data chunk, which is where the user's data that they actually store will be, is then that is added into the total capacity. Um, yeah, and we're gonna have a user pre-allocation. So the rest for now does not matter. Okay, I think for now that is good there. So date last modified should be exact same number, and it is. So 1 okay, perfect. The date that was created. And we are storing this in 8 bytes. So yeah, this shit is confusing as hell, but it's all good. Um, Bytes. Okay, so we serialize. Oh, hmm, serialize a field. Um, yeah, fields are a little bit different because that actually gets passive data. DB header, we can just do it straight up like that and serialize it in there. Um, okay. Okay, let's try writing to a file now. Let's see. So we have a header. We want to write the values stored in our header members here, the struct members, into a file. So let's do that in, I don't know, let's make a new, we don't have to make a new file. Let's just add it to our library maybe. Um, dot Odin library, and other QDB to send a header from database header. Let's just call it append DB header. And this will return, I don't have any error handling right now, so it'll return it'll return nothing for now. So it needs to pass that, and then we need to do OS OS dot open. I always forget what you need to pass this freaking thing. You need to pass it the path, flags, read, write. I'm gonna give it read, write, and then mode. Okay, so file, just that, and then we're gonna just create a new file called, or wait, open. Create. We want to create it first. Let's create a path. So wherever the binary is, it'll just be dot slash sample dot chunky. I'm debating on the file extension whether I want to do chunky.db or chunk.db or dot chunky. I will do that for now. And pass our flag create. Clear. Start creating. And start right. It just returns. Okay. Oh, you know what? We can hold on, I'll get to it in a second. Right text in data. That's right. Shit. Transmute. Uh, right. Oh fuck. 56 bytes. The array expression may be sliced with transmute byte. What? Cannot slice H of type database header. Okay. Hmm. So our header is 56 bytes that are already pre-allocated based off the size that I've said in when we declared the type. Write expects a non-fixed length of bytes. Type of data. Okay. So this cannot transmute H to Slice of unsigned 8-bit integer. 56 versus 16 bytes. Our head is 56 bytes. What is the 16 bytes? I don't know. I might have to. We can't just pass it H because it's expecting that. So I have to transmute my bytes. So we can make a, not transmute, serialize my struct, I should say. Serialize. Let's just call it serial because I need to figure out the name for that in a second. Oh, I know. Serialize. Serialize header. So it takes in 56 bytes, 8, right? You unsigned 8-bit integer. Am I correct in that assumption? Where was I working at? Oh, where was I doing this at? Right? Here. Um, and it's supposed to return a non. Well, I don't think we can do it this way. I think we have to do it like that. Takes that in and then just return. So it should be um, how does that work? Oh shit. I can't serialize that. I can't import the, I have to, dang it. Oh, not transmute. This shit is confusing. Cannot transmute header. 56. How do you get how do you what are structs stored in? Like underneath the word, the keyword struct, what is that? Um I don't even know how I would ask that question. Structs there, no structs are typically, I think you mean confuse Hitler. Structs are compiled type right. Struct online and pointers cheaper on 64-bit systems. Pointers including pointers are 64 bits or 8 bytes, but there's a different from pointer to a struct. Okay, so should I do a pointer to the struct then? If a pointer to a struct is 64 bits or 8 bytes, and we want to convert this to that, uh, not assign. What? going on? This shit is not making any sense to me. Can I transmute H2? Because H is 16 bytes because it's 56. What? But a pointer 2 is 64. I I genuinely like this. Oh, man, come on. Mm, I don't know what to do here. We have our struct. We need to serialize the data in the struct itself, or a pointer to the struct. Write only takes in. Data is in array bytes. We cannot transmute our struct to that. I don't understand this. 8 versus 16 bytes. What is 16? The header or what? I don't understand. Let me see. Let's pull up our type here, and I'm going to. So it's not the header struct. What the fuck is the 16 bytes coming from? The pointer to it is 16, ain't it? No, and we can't. Or do we make this pointer to the header is that, right? And then we want to put this. We can't do that either. 448 bytes versus 16 bytes. So header is, I think this would work. Let's see. Right. So let's just do serialize. Passive pointer to, oh fuck. See now no. What's this? Pointer two. So I don't understand. How is it that a pointer to something is 64 bytes, but we're still passing the struct itself. So we'd still need to actually. Oh, wait. I'm running myself in circles here. I don't know. Let me look at the field for an example. So Make new field. I need to move it, but it's over in serializer. Let's use this as an example. Okay, so let's serialize the header. Right, so it takes in a header, which we kind of already did, a pin header. Right. And it returns a non-fixed length of an array of a slice of fucking bytes. God damn it, a slice of bytes. Okay, result is it? I mean, dependency. So the thing is, though, append result. Oh, wait, did that wrong. This is supposed to be over here. Oh, you don't have to use make here. Nice. Sweet, dude. Okay, so we're serializing everything in here, but when I actually make the header, um, header, I'm already serializing a lot of shit in there. So, result. So I guess we don't actually have to do it here. We can make everything just pass this header, and then result. Hmm. Header dot. Since everything is already serialized in here, or will be serialized in here, all we have to do once we pass the header, everything's already technically serialized, but we need to put it inside here. So this could be like a little helper for now, because I don't quite understand this fully. So header dot magic number. Um, magic number is right. The magic number is how many bytes? The magic number is 1 byte, I believe. Yes, it should be just no. Fuck. Hold on. Damn it. This shit is so confusing, man. Um, hold on. Serialize string. Dot magic number. SMT. God dang it. This is such a fucking clusterfuck. Uh, 10 bytes. 10 bytes. So where was I working at? Where the fuck was I? So this is going to be 10 bytes. No, whoa, 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 whoa. So I'd have to do fuck, I'd have to the length is already known, right? So dot dot magic number. So let's just try that first. We know what we should get. We should get exactly what's here, right? Um, we should get that array of bytes. Um, I just want to try something. So let's go ahead and we're going to do serialized header. I can honestly just do this in header because we're not doing anything. Just pass this lib. All right. And we're going to go back to main and we're going to do something different. So we know how many bytes we're supposed to get. Right? So now we can do data dot make db header. We don't need to pass it anything. So we'll call it header is equal to that. And then we're going to do data dot serialize header is going to be pass a header. T dot println um, that. And let's see what we get. Odin run. There it is. Perfect. Okay. So because the length is we've already serialized everything, I don't need to do all that extra bullshit. Cool. Um, oh my God, my head hurts. This is good. This is very good. So we know that is our magic number is set. So now we can go ahead and do I'll leave this here. That there. We're gonna append this to our result header dot what else do we have? Header dot created at and then last modify at. Oh, hold on, wait a minute. Procedure dynamic. Hold on. So result is you and created at is that. So we had a fixed size on those. What's the problem? Magic number. Yes, this is fixed. So we would have to do the shit where it's like there's got to be a cleaner way to doing that. I don't want to do that 8 times for each. So this first byte, yeah, that doesn't, it's not clean at all, but I just want to, hold on. Yeah, that'd be a terrible idea. 0, 1, 2, 3, 4, 5, 6, 7. There's got to be a better way to do that. There's no way that's the only way to do that. 0, 1, 2, 3, 4, 5, 6, and 7. And the same thing for last modified at, I believe. So we're appending each byte. There's got to be a way to just jump bytes. So like a what do they call it? The offset equals 0. Um, no, or we could just do like a or be in header. We got create that and B, and that should be good, right? So let's try it again. So for the for created modify. So this will be right. There's an individual byte. Okay. So we're pinning each byte. Now, are we pinning it as an array though? I think we are because we're going for each one in this array appended. I don't think that's gonna be good. I need to serialize the created at again, which I already. Hmm. Right. So that is a problem. Well, yeah, this is becoming so this would become a problem then, right? No, 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 because this is just a serialized database header. So it will all be one fucking array of all the bytes in it. So this should be fine then. Like the first 8 bytes we have our or first 10 bytes we have our so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have our magic number. The next what 8 bytes is our cre created at timestamp. Okay, so that should be fine then. We are appending it all to one large array. Cool. Um, so uh, and first 10 bytes and next 8 and next 8. Okay, what else do we have? So this is coming along. So right now, that's all we're worrying about. So we can serialize a header. That means we can then write this to where are we? What am I looking for? Common. Um, actually, don't put this in common. We're going to not do that. We're going to put this in header. That way we don't have to import nothing. Serialized header. This all just needs to take in a lib dot header. And header is, we don't need to transmute it. We could just pass, uh, no, this gets passed serial. There we go. Okay. So now we should create the file and then we should write to the file, and then that should be it. So if I do Odin run main, I didn't call this, I don't think. Let's append DB header. Let's go back to main, and we can uh, data dot append DB header, and we're going to pass it header. And let's see, there's our example.chunky file, and it's bytecode. Permission denied. Oh, what is it? Is it chmod x plus example chunky valid file format? Okay, wait a minute. Wait a minute. Wait a minute. How would we view this example.chunky? Create. I don't think I gave it. I don't think I. Um, oh, let's not. I think I'm missing something. OS open, read write, read write. Well, we're created. In this instance, we do create the file, which technically doesn't need to be done here. So now I can actually, let's try that out. So this, what does this mean? Open in default app. I don't know. Should just be bytecode. How to view. Um, Make a file readable for you. Make a file readable for everyone. All right. So chmod a plus r chunky. Uh, chmod a plus r example dot chunky. Oh, okay. It created it. It did not write anything. So let's make sure we are still printing or we're getting something. Yeah, there's our bytes, but it's not writing to anything. Let's handle that error real quick. Getter before OS close. Success is the okay. We're not getting success. Our serialized header is good. Um, read and write. Shouldn't there be like an OS dot append? OS append? Oh, my headphones are fixing to die. I'm sorry. I guess it's a good stopping point. Made some progress today. Uh, I will be working more on this in my free time. So thanks for watching. Peace.